Okay, one more. We're going to compare g of x equals 3 times the absolute value of the quantity of 4 minus x to the absolute value of x. And as with the previous example, what I would have put in for x previously is now going to be the 4 minus x just before we take the absolute value. Now we know what transformation is occurring by multiplying by the 3 outside of the absolute value. We've got the shape, the V shape of an absolute value graph from this. Multiplying by 3 is going to give us a vertical stretch as the last step. But what's going on inside with the 4 minus x, I think we might be a little surprised by. So what x would I have had to put in for getting 4 minus x to equal -2? That would have to be 6. I'd have to put in 5 to get 4 minus x to be -1. And for 0, I have to put in 4. And then I'm going to guess 3 and 2 respectively here, but let's check it. Get 4 minus x to equal to 1. Subtract 4, just like I've been doing in all the previous ones. Yes, x has to equal 3. And finally, to get 4 minus x to equal +2, subtract the 4, and x would have to be 2. So we're going to be plotting the points 6, 6, 5, 3, 4, 0, 3, 3, and 2, 6. I want to talk about, after showing you the graph, what the transformation must have been that we had inside, followed by the vertical stretch by factor 3, and perhaps talk about the order of the transformations being important. So let's see here. I can go by ones in each direction on this. One, 2, 3, 4. 1, 2, 3, 4, 5, 6. Actually, there. Okay, 6, 6. 5, 3. 4, 0. Messed that up. There's 6, 6. 5, 3. 4, 0. 3, 3. And 2, 6. Connecting with the V shape, ignoring those first 3 that I plotted. And again, my labeling in both the X and the Y direction would be by ones. Oh, by the way, the domain and range. The domain of the absolute value is all real numbers. Whatever has occurred inside there with having 4 minus x before taking the absolute value, we can put anything we like into 4 minus x and then take its absolute value. multiplication by 3 outside is a vertical change, and so would not affect the domain. The range of absolute value is starting at 0, including 0, and then going to infinity. Well, stretching that by a factor of 3, we're still going in the same direction. That's not changing either, as it would seem apparent from the graph. Real quick check on the calculator. 3 times the absolute value of 4 minus x. We can get absolute value by pressing the math key and going to the second submenu. Put in that 4 minus x. This one, if I want to see as far as 6 in the y direction, let's keep -5 to 5 with a x scale of 1, and then go from -4 to +6 in the y direction with a y scale of 1. And our points. Oh, well, we wanted to see 6 in the x direction as well. So let's switch that. -4 to 6 in the x direction. Now this should look more like what I have drawn. If I trace on that, put in the 6, and y is 6. Put in the 5, we should get 3. We do. Put in the 4, we should get 0. We do. Put in 3, we should get 3. And it is. And then put in the 2, we should get y is equal to 6. So I predicted correctly. Now, what was going on inside? If we take 4 minus x and rewrite that as -x plus 4, and then factor out a -1, work our way from the inside out, that would tell us that we're shifting right 4. Then we're getting a reflection because that's inside of the absolute value, the main function that we're comparing to. That's going to give us a reflection over the y-axis. And then outside, we had that vertical stretch by a factor of 3. So as a check of that, the points I started with for graphing the basic absolute value function. If I shift those to the right 4 units, then let's see here. Okay, I had a mistake in there, but I'm going to leave it because it's going to help me make the point about the order that you apply transformations in mattering. Now we had overall g of x equals 3 times the absolute value of 4 minus x. If we rewrite the 4 minus x inside as negative x plus 4, if we apply the order of operations, that would tell us our first transformation is to change the sign of the x's, which gives us a reflection over the y-axis. However, that doesn't give us very much interesting if we were to graph these 5 new points, because y1 equaling the absolute value of x has y-axis symmetry. It's an even function. I have the same 5 points, just in a reverse order here. But then add 4 to all of those. We're shifting right 4, 6, 2, 5, 1, 4, 0, 3, 1, and 2, 2. Now, don't get thrown off by the fact that I had the right 4. That did work out correctly. We saw the graph. We checked it on the TI-84. You might think, wait a minute, he doesn't have a -4. What's going on there? Okay, hold on a moment. And finally, vertical stretch by a factor of 3. Multiply all those y values by 3. And these are the same 4 points that I'd come up with, as you see here. Plotted those 5 points. Okay. Now, here my mistake was thinking that I needed to factor out the negative and work my way out if I shifted right 4 first, then reflected over the y-axis, and last applied the vertical stretch. Well, taking the 5 original points from y1 equals the absolute value of x. If I go right 4, adding 4 to all of those x coordinates, here's what I get. Then if I reflect over the y-axis, I'd be changing the sign of those x coordinates. And then if I apply the vertical stretch, multiply all those y coordinates by 3, there's supposed to be a 2 right there. Those 5 points are not on our graph. If I look at what's going on just at -2, try focusing this. At -2, we're getting that y is equal to, looks like 18, not 6. And in fact, 4 minus -2, that is 4 plus 2, or 6. Its absolute value is 6. 3 times 6 is 18, not the 6 that would be predicted if I had gone in the order of applying the shift right 4 first, and then reflecting over the y-axis. And then last, applying the vertical stretch by the factor of 3. It's got to be in the order of reflecting over the y-axis first, then going right 4, and then the vertical stretch. That's all for now. Hope this has helped. And if it has, please like the videos, subscribe to the channel, and if you know anybody else working on some of the same material, needs a little extra help, share it with them. Have a good one. I'll see you in the next one.